elc128 worksheet 20. This is a little bit more maintenance and then a program and some programming considerations. What will happen to PLC terminal connections over time? You cannot tighten them tight enough for them to stay tight over time. They will loosen up. So you tighten them to proper torque specs so that you can't pull the wire out, but over time the heating and cooling will cause them to loosen back up. What must a technician be cognizant of in terms of PLC applications within a panel? Maintenance concern. You know that your wiring will get loose over time. You're in a harsher environment typically if you're using a PLC, so you could have some odd things that are connection related in the rack, etc. Now most of that's pretty robust, but you never know. Some PLCs have batteries. Where is the schedule found for changing them? I worked at a company one time and we didn't know they had batteries till they went dead. Well, we did, but nobody did anything about them, and that happens. So if you've got a PLC, then the manual will tell you what kind of battery you need and how often you should change them. Newer PLCs like the clicks we have now have capacitors. And what is the purpose either of a battery or a capacitor? And that is to keep it from losing its mind if it loses power, basically. And on the click PLC, if you leave them off for long enough and you turn them on, you'll have a blinking fault light, and it's the battery light. And so the way to clear it is to unplug it, plug it back in, or unplug it, count to 10, and then plug it back in. And I found that in the manual, and that's where you would look to clear faults. Usually PLCs will have a fault list in the manual, and basically based on the fault you can figure out how to clear it. What happens if the battery dies or the capacitor fails and power is lost to the processor? In older processors, they would lose their mind, and just, you can't really say any one thing would happen, but weird stuff would happen. So if you have a PLC, then it is important to keep the batteries changed if it has batteries, and keep power on it as much as you can. The PLCs I've got for the class, if they fault due to power, no big deal. How can a panel be cooled with compressed air? PLCs will take a harsher environment than say a computer, but still anything we can do to keep the environment a little more comfortable will help the PLC long term. And there is something out there called a vortex cooler, and I saw it at when I worked at Corning in Midland, outside in their outside their process where they did the waste. Okay, they had panels and they were cooled, and it was actually with compressed air. It was kind of interesting because it could be 90 degrees, you open the panel and it was like a little breath of fresh air. But they do use compressed air, and that's a bad thing, but they work pretty well, because when you let compressed air out, it will actually absorb heat out of the air, so it gets a cooling effect. So that's kind of neat. You don't want a lot of compressed air, just a little bit, just a little wisp, and we could hear those things just wisping a little bit. I'm going to jump down to 13 for a minute before I come back to the program. What's a subroutine? What's the benefit of a subroutine? A subroutine is a second ladder in your ladder logic program, or a third ladder, or fourth ladder, or fifth ladder. You can have as many subroutines as you want. By default, you always start in your main ladder, and then you can add different ladders. The benefits of subroutines is that you can break different parts of your program down and put them in their own subroutine. For instance, when we did the stoplight program with the 6 timers and outputs, we could have put the timers in one subroutine and the outputs in another subroutine. And then if we had a timing issue, we could go to that subroutine. If we have an output issue, we can go to that routine. More likely you're going to see it in terms of, if I'm in manual, I'll go and run this logic. If I'm in automatic, I would run logic in a different subroutine. That would be a better approach maybe to doing it. You can do a stoplight that way. So makes it a little easier from a troubleshooting standpoint. Otherwise, you can put everything in one ladder, but I have seen programs that are 300 and 400 pages long, and if you're looking for one rung out of 300 or 400 rungs, then it takes a while. If you can go by the subroutine name and you know where your problem is, and you can zero it down to 5 or 6 rungs, then your troubleshooting is faster. So that's clearly a benefit. There is a negative to subroutines, and I'll come back to it. Basically, if you turn on an output, well, I'll tell you. If you turn on an output in a subroutine and then you don't go back to that subroutine, nothing turns that output off. So sometimes you can get outputs that are left on because you were in a subroutine that you're not in a subroutine anymore. So you've got to, there are some things you can do to take care of that and break up your program. I call it sectionalized programming because it makes it a little easier to follow. How are additional ladder file subroutines created? I think you right mouse click on the main or subroutines and click, and it will create one. Allen Bradley and click have a similar capability. You can certainly make subroutines in Allen Bradley and click. How do you get from the main program ladder to another? I think in click it's call. And when you use your call function, it will ask you what subroutine you want to go to. And at the end of the subroutine, you may or may not need a return. If you don't need it, I usually don't use it. Usually, though, when it gets to the end of the subroutine, it will go back to where it was called from, to the next line down. Subroutines also help in the standpoint of if you've got lines of code you don't need scanned because you're in manual and it's on automatic mode, it shortens your program, which speeds up your scan time, which makes it more likely to operate better. Okay, now the program. An anti-tie down circuit. Okay, so close your eyes, just listen to my voice. 2 push buttons pressed nearly simultaneously, and I say within a quarter of a second, will cause a 5-second cycle to start and then complete. Okay, so I want something to happen if I push 2 buttons at the same time. Well, you could just AND those 2 buttons together. And when people first started doing this, that's what they did. They would AND the buttons together, so you had to make both buttons in order for your cycle to happen. But people would cheat that, and so what they would do is they would take one button and they cheat it, or they would tie it down, or they would wedge something in there to keep it pressed all the time, and that way only one button controlled your process. And this was a safety thing because you wanted to know where somebody's hands were. Usually the buttons were not side by side. They were far enough apart you had to use 2 hands to operate them. So when you would cheat the button and you only had to use one hand, then you could stick your hand in the process and get it mangled, cut off, or whatever. So it's a pretty common safety circuit to have two buttons that you have to push pretty close to simultaneously. I say within a quarter of a second. You can make it whatever you want. So you're going to have to use some kind of timer. So when you push a button, you're going to push that button and you're going to start a timer. And if you don't push the other button, by the time the timer ends from the first button, you don't want the cycle to happen. In other words, you can't cheat the button. You can't hold it down. So you've got to have the buttons released and you've got to have them pushed each time you want that cycle. So if the buttons are truly released and pushed within a quarter of a second, then you want a cycle to come on for 5 seconds and then complete. And the other thing I would add to this is if at any time you let go of the button, that would stop the cycle early, or the cycle would stop immediately. So that is the programming exercise. It's only a couple rungs. It involves using a timer, a little creativity, and eventually I'm going to have you programming stuff that I'm not going to show you. This is something that people have done hundreds of thousands of times. So it's not like it's something new that I'm asking you to program. So I wanted to describe it thoroughly. I would do it probably in probably 2 or 3 rungs. You could probably do it 2 or 3 rungs. It's not that big a deal, and it's one of those things you would then have in your memory as far as being able to program it. So if you had to have simultaneous inputs, you could get them, or nearly simultaneous. I don't think you can ever do completely simultaneous. That's why you have to use a little bit of a adjustment. Anyway, that is your programming. I don't know if I'll put that out there. I might at some point, but I'm not planning to at this point. As far as a start or a help, y'all can do this. Anyway, good luck. Thanks for watching.